Okay, so now let's see the examples. Let's see the example. Yeah, I give you several example. So first one, f of sy equals 4 subtract x squared subtract 2y squared. So as we say, if we want to consider the first order, find the all first derivative of the functions. So for the first functions, yeah, so we consider it's x, y. So our variable is x. So as we say, we should, for the variable y, it's actually, when we consider the variable x its derivative, we could view it as a constant. For example, this case, okay. For example, we consider the point 23, and consider its derivative. What's this? It means that we will fix y equals 3. Fix y equals 3, right? So fix y equals 3. Consider the function 4 subtract x squared subtract 2y squared. So we fix the y value should be in a constant. When we consider the variable x, we fix the y value and let y be 3. So actually you could view it this way. It's 4 subtract x squared subtract 2 times 3 squared. This function. You could view, yeah, actually we consider this function x3. We consider this function. And for this function we consider its derivative. For this function we consider its derivative. Okay, here I could rewrite by this one. You could view it this way. Yeah. So its derivative. So indeed, it's something like a single variable. Single variable is derivative. So single variable derivative is just negative 2x squared, right? Negative 2x squared. Because here this part, originally 4 is a constant. So of course for this function, 4 its derivative is 0. But this term, when you consider the variable is x, its derivative, then you view it as a constant, then its derivative is 0. So its derivative is 0. And the first term and the last term, all of them are 0. And x squared is derivative is negative 2x. Sorry, negative 2x. This one. But so for each, actually, so here we just fix y equals 3. But if you fix y equals any value b, we have the same result, right? Any value b, you will get this one. So indeed, this term is exactly just view it as a constant. So we just have this term. Its derivative is negative 2x. Otherwise, all of they are constant. So their derivative is 0. So it's negative 2x. This one. And here we could derive. We could just erase it now. So here you could view it this way. In this case, we fix y. So you could view it this way. Let me see. Here y is constant. Okay, so here y is constant. So y is constant in this case. So negative 2x. And what's this? If we consider this, then in this case, the variable is y, then x is constant. Yeah. So x is constant, so 4 is constant, its derivative is 0. Subtract x squared, x is a constant, when we consider variable is y, so it's still 0. And negative 2y squared is its derivative. Our variable is y, so this guy is derivative negative 2, and put down the power 2 times y. For the power we subtract 1, so it's this one. So it's negative 4y. And for example, f sub x 1, 2, just plug in the value negative 2 times 1, so it's negative 2. And f sub y 1, 2 is exactly just plug in the value 2, so it's negative 8. Negative 8. This one. Okay. It's the first example. The second example, let's see. Second example. So it's we consider as the partial derivative with respect to x. Then y is a constant. And we say y is constant. So here y just equals some constant. So in this case, here this constant is constant. Just constant times s squared, s cubed. This 10. So first 10 s cubed is derivative is 3s squared. Second 10 y cubed is constant, so we could write down firstly. It's something like for example it's something like s squared times 2 cubed. So when you consider its derivative, just for a constant we could write down firstly and consider this guy is derivative. S squared is derivative 2x. Okay, so this 10 you should know what it means. And then subtract 2, here y is constant. So constant is derivative 0. So indeed it's 3x squared plus 2xy cubed. And the f sub yxy. F sub yxy is, this guy is, now variable is y, so x is constant. If the variable is y, consider its derivative with respect to partial derivative with respect to y, then x is constant. So s is constant, so constant is derivative 0. And the constant we could take out, but y cubed is derivative, variable y is derivative 3 times y squared. And subtract 2 times y squared is derivative. Y squared is derivative, put down the 2, so it's 2y. This one. So here is 3x squared y squared, subtract 4y. This one. So it's second one. Yeah. And again we could consider some point 1, 2. So just plug in the value. 3 times 1 squared plus 2 times 1 times 2 cubed. So it's 16, 3, so it's 19. And f sub y 1, 2, and it's 3 times 1 squared times 2 cubed, 2 squared, so it's subtract 4 times 2. So it's 12, subtract 8, so it's 4. This one. And the third one. Now the function is this one. Okay, the function is this one. Sine of x over 1 plus y. So as we say, now we consider the variable is x, its derivative, partial derivative. F sub x xy. So now y is, in this case y is constant. In this case y is constant. So it's something like sine of x over 1 plus y is just a constant. So for example y is 4. For example if we say y equals 4, then what's the derivative? For this function, what is its derivative? Its derivative just, here is the inside function, and we say here is the inside, and here is the outside. So its derivative, outside function is derivative cosine, and the inside will keep it 1x over 1 plus 4. Multiplied by inside function is derivative. Inside function is derivative. Here is constant, so x over this guy, so it's 1 over 1 plus 4 times x. So its derivative is exactly the constant 1.1 plus 4. This one, right? This one. But here I just give you the example when y equals 4. Here is exact. Here this one is the example when y equals 4. when y equals 4. But in general, y, then we should replace 4 by y. So here just replace 4 by y. Replace 4 by y. So here is exactly this guy. Here is cosine x over 1 plus y times 1 over 1 plus y. This 10. This 10. So now you come back to this question, you could see actually it's the inside and the outside function. So when we consider its derivative, just use the chain rule. Outside function is derivative is this 10. Outside function is derivative is 10. But in this case, we should keep inside. And the inside function is derivative. Now our variable is x. Our variable x. So for this 10, 1 plus y is a constant. So it's just 1 over 1 plus y times x. This 10 here now is constant. So its derivative x is derivative is 1. So 1 over 1 plus y. This one. This one. Okay. Yeah. Okay. So now and for the case, it's partial derivative with respect to variable y. I will write down and turn it here. So now f sub y. So in this case, the constant is x. The constant is x. So now what's this? The constant is x, but it's the same. Outside function sine is derivative cosine, so the first 10 is the same. First 10 is the same. But second 10, inside function is derivative is different. So here I could write. Okay, so second 10 is this 10, this one x over 1 plus y. So now our variable is y. So it's something like x is a constant. So for example, let x be 4. For example, if we let x be 4, for example, x equals 4, then what's 4 over 1 plus y? What's the derivative? What's the derivative? So when we consider its derivative, you could write it this way, right? I mean, 4 over, of course you could use quotient rule, but here numerator is just 1, just constant, so you could rewrite it by this way. 4 times 1 plus y to the power of -1. -1. And use the power formula, power rule. It will be easy to solve it. 4 times put down the number, put down the power, and 1 plus y to the power of -1 subtract 1, so it's -2. And the inside function is derivative is 1. This one. It's 10. It's 10. It's 10. Okay. But now here inside function is this one. So now we should replace 4 by x. Replace 4 by x. So now it's x. So it's x. Okay? So its derivative is exactly this one. This one. So you should multiply by this 10 is derivative. This 10 is derivative. I mean the variable is y, so it's x. Put down it's constant, so put it down. And the 1 over 1 plus y, again, we could rewrite by 1 plus y. Let me see. Okay, so you cannot see this one. So here, let me see. 1 plus y, so it's 1 plus y to the power -1. Just this one. Yeah, so its derivative is -1 times 1 plus y to the power -2 times inside one is derivative, so it's this one. It's this one. Yeah, this one. So I erase it. Yeah, for this section is basic one, so you should practice. You should practice more examples. But they are related to the single variable function, their derivative formula. Okay, so here is partial derivative of x, partial derivative with respect to y. But here we could, yeah, anyway, Let's yeah, just that. So here I could. So inside function is derivative is actually this one. Okay, and then the next one, is x to the power of y. Okay, so when we consider the derivative, the variable is x. The variable is x, then y is a constant. So here is the important concept, as we say. So when we consider this one, y is constant. Y is constant, for example, you could see this way. X to the power, it's just a constant, so for example, x cubed. It's the case when y equals 3. Then what is its derivative? The variable is x, right? So what is its derivative? d dx. Just 3x squared, right? 3. Just put down the power, and for the power subtract 1. This one. So now it's y is constant. Just put down the value y times s to the power y subtract 1. Just. Okay. And how about partial y? Partial y, then now the constant variable is y. So the constant is x. S is constant. So now s is constant. So for example, s is constant. For example, s equals 2, then it's s equals 3. So the function is 3 to the power of y. This function is derivative. Now variable is y. So this function is derivative. d dy. So of course you should recall the formula a to the power of y is derivative formula. So you should recall it. Okay, so this part you will see, and let's recall this result. This formula. Let's recall this formula. So you should come back to this form, its derivative formula. F of x equals a to the power of x, its derivative formula. And the general case, f of x to the power of a of y of x is formula. So if you remember that, of course you could just follow the formula, derivative formula. Otherwise, if you remember that, how to get it? The variable x is in the power. F of x contains the variable x, and it's in the power. For its power, we want to consider its derivative, so we should put it down. So how to put down the power? In both sides, we consider natural log, right? We consider natural log. So natural log. So in this case, indeed, we could put it down. It's equal to x times natural log a. This one. And then now, indeed, we can consider its derivative. And then here is the inside, and then here is the outside. So the derivative is inside function. Outside function is derivative 1 over natural log. Natural log is derivative formula. This one, right? So 1 over inside function. Inside function is reciprocal. So inside function is reciprocal 1 over f of x. Its outside function is derivative formula. And the inside function is derivative is f prime x. Inside function is derivative. And here equals, here natural log a is just a constant. A is a constant. Here a is a constant. So natural log a is a constant times x. So its derivative just natural log a. Yeah. So finally, if you multiply by f of x in both sides, you will get prime x equals f of x times natural log a. This one. And it's exactly our result. But f of x equals ax. So it's exactly ax times natural log So of course you could memorize this result directly. Otherwise, if you forgot this result, you could recall it by this way. Yeah, it comes from this detail. And now if it's the form to the power of f of x, then what's this? You will have some similar way to solve it, but different part is here. We replace x by, sorry, it will be better to write down by another function. Here I replace f of x by y. Okay, that's fine. G of x. Yeah. So now here we should replace x by g of x. The difference is replace x by g of x. So now here natural log is constant take out, but here it becomes g prime x. So it becomes, we have this result, this one, prime equals g of original is this one. Natural log f of x equals g of x times natural log a. This one. We take natural log in both sides, then and put out g of x, you will get this one. And consider its derivative, and it's constant, so it's g prime x times the constant natural log a. The constant natural log a. And so finally, g prime x here it becomes g prime, or we would like to know f prime x. Sorry, f prime x is exactly f of x times natural log a times g prime x. This one. So finally, and the f of x is exactly the original term. This one, natural log a times g prime x. Yeah. So general formula is this one. Yeah, and if you remember that, you could build it this way. Y equals a of g of x, then dy dx equals, we have 3 terms. First term is KB cell. Second term, for its base, we can see it's natural log. And for its exponential, we can see that it's derivative. So general formula is this one. It's our general formula. This one. So of course you could memorize this result directly to solve this question. Okay, yeah. So its derivative is, but now in this case, g prime, of course in this case we should our variable is y, and derivative is its derivative with respect to variable y, so it's equal to itself, 3 to the power of y, and we should multiply by its base. We take natural log, and its power we consider its derivative, but its derivative is 1, so we don't need to write down anything. So it's exactly this one. Yeah. So, but it's just the case when x equals 3, right? And then now general case is general case we should replace 3 by x. Because now variable y, we consider its partial derivative with respect to y. So replace 3 by x. So the result is itself multiply natural log x. Is what we want. Next is the more general case. X to the power y squared, y times g squared. So now we consider. So now we have 3 variables. And you could use the general formula directly. But first of all, if we consider if the variable is x, then in this case yg, these 2 variables are constant in this case. So for this function, for its power is constant. It's constant, so it's something like s2 to the power of some constant. For example, this one. And this guy, its derivative is just put down the power, and for the power subtract 1, right? So just put down the power y times g squared times x to the power of, for its power subtract 1 is 10. Since now our variable is x, so its power is constant. Okay, so that's why I say for these examples, if you know the concept of partial derivative, then it's not difficult to understand. And of course, you should know the single variable function their derivative formula. Okay, and here, if now our variable is y, or the last one our variable is g, then you will see if our variable is y, then xg is a constant. If our variable is g, then xy is constant. So in these two situation, x is constant. So here x is constant. It's constant, and here its power. We have for the variable it's over here. So it's something like this form. The base is constant. So in these two results we will use this formula. Okay, so for example here, is the case when x equals 2, so it's 2yg squared. For example, just consider the case when x equals 2. Then you could solve these two results. I mean, you could view it this way. This one, what is its derivative? If we consider partial derivative with respect to y, then we have 3 terms. First term is keep itself. So in this case, it will keep itself, 2yg squared. And the second term, we consider natural log. It's for its base, we consider its natural log. And the last term is for its power, we should consider for its power its derivative. So now for its power we consider its derivative, but now we consider the partial derivative with respect to y. So g is also a constant. So its derivative is exactly g squared. Right? G squared is constant. Constant times y is derivative is constant. G squared. But now, so I just follow the example again. So, but if now we consider variable in g, for x is also a constant, so you also could use this example. So for the first term, so we still have the formula, and the first term is itself again. And second term, for its base, we should consider its natural, so it's the same again. Natural log 2 times inside and its power. Now the variable is g, so y is constant. So yg squared divided by g. Now y is constant. For example, y equals 3. Then what's the derivative? 3 times 2g, right? 3 times 2g. But now we use the y, so we should replace 3 by y. So it's this y. So it's y times 2g. So this term is y times 2g. This one. But it's the case when we just, since x is constant, so we replace x by 2. But in general, it's x, so we should replace 2 by x. So we should replace 2 by x. So here is exactly 2x. Sorry, we should replace 2 by x. So our solution should be this one. X, natural log x, here. Let me see the final solution. This one. Okay, we still have 3 examples. xyg equals exponential xy times natural log e. So what's this? What's this? Okay, so again, we have three variable. Now we have three variable. So first one, if variable is x, yg is constant. So here is constant. So just this 10 has the variable x. So and the exponential is derivative. Now y is also a constant. In this case, yg is constant. Yg is constant. In this case, yg are constant. So for example, if y equals 3, g equals 4, so it's exponential 3x times natural log 4. This one, this function is derivative. This function is derivative. So its derivative, exponential function is derivative itself. Times, for its power, its derivative is 3. Right? And natural log 4 is constant, we keep it, this 10. Okay? So, but now we should replace 3 by y, replace 4 by g. Right? So actually it becomes which one? Exponential function. If you see exponential function, you always have this 10 itself. You always this 10 itself. But inside function, you should consider its derivative. xy, you should consider xy is derivative. But now the variable is x, so its derivative is y. Okay, so it's the first 10 is derivative. And second 10 is constant, so we just keep the constant. So it's this one. And if the variable y is similar, because in this case xg is xg are constant. And xg are constant, then this 10 is also constant, it's similar. And it has a variable y, so still consider its derivative, so still have this 10. But inside, for its power, its derivative now, the variable is y, so derivative becomes x. And times natural log g. This one. And then the last one, the variable is g, so xy are constant. So in this case, xy are constant. And the xy are constant, then here it's just constant, so we could put it down. Keep it. Natural log g is derivative. Variable is g. Derivative is 1 over g. It's reciprocal. So that's the final result. Final solution. Okay. And next one is this one. And the next one is y over 1 plus x subtract x over 1 plus y. This one, this function. 7 is the next. We still have 2 examples. Yeah. And the 7th one is this one. The 7th one is this one. So here, we consider here, we could rewrite it by this way. Since we have the fraction, so we could rewrite it by this way. Because when we consider its derivative, probably if we have the form to the power of some number, then consider its derivative will be easy to solve it. Compare with quotient rule. 1 plus y to the power of -1 is 10. But probably sometimes if both of numerator and the denominator have the xy terms, then probably sometimes you should use quotient rule directly. Yeah, you still need to use quotient rule. Anyway, so now let's consider partial derivative with respect to x. So first 10, partial derivative with respect to x. So y is constant, so we just this 10 is derivative, right? Constant we just keep it, and then this 10 is derivative -1, put it down, 1 plus to the power -2. Multiplied by inside function is derivative, so it's 1, it's still 1, it's still 1. Yeah, this 10 is exactly d dx 1 plus s to the power -1. And second 10, here is constant, so just keep it. X is derivative 1, so it's 1 times this 10, so it's 1 times this one. And it's enough to write down in this way. Yeah. And let's see the difference. But now if our variable is y, so for the first 10, this 10 is constant times y, so it's derivative, just constant we keep it, y is derivative 1, so it's just exactly the constant 10, this one, the coefficient is coefficient, and here variable y, s is constant, so s we keep it, and 1 plus y to the power -1, now its derivative is just similar by this one, right? So put down the power, and 1 plus y to the power subtract 1 times inside function is derivative 1 multiplied by 1, and this 10, actually this 10 is exactly d dy 1 plus y to the power -1. Okay. Let me see. For example, here we could consider s of x 0, 0. What's this? This, oh, sorry, it will be 1, 1, 1, 1. What's this? Then it's 1, -1 times 1 plus 1, 2 to the power of -2, so it's 2 to the power of -2, subtract 1 plus 1, 2, -1. So it's 1/4 is 1/2. So it's -1/2, 1/4 subtract 1/2. So it's -3/4. This one. Yeah, just of course we could plug in some value, some number. Okay, so now let's see the last example. Okay, so now let's see the last example. The last one is arctangent. Even tangent, we still can consider it. Arctangent. So of course you should memorize the tangent function. Probably we could, yeah. Let's find. We could consider what's the difference. Tangent is square root of y. G. So of course you should recall the result. Arctangent is formula. So arctangent is formula is 1/s squared, right? This one. And the tangent is derivative formula is secant square. This one. So okay, so now let's see f its partial derivative with respect to x. So here is inside, here is outside. So we still use the chain rule. Here is inside, here is outside. So we still use chain rule. So outside function is derivative, just this one. Inside function 1/1 plus inside function is square. So when we consider chain rule, we should consider outside function is derivative firstly. And the outside function is derivative formula is this one. So it's 1/1 plus s squared y is square. So its outside function is derivative. And multiplied by inside function is derivative. Inside function is derivative. Now inside is x squared plus x squared times y. X squared times y, x squared times y, but now our variable is x. Variable is x, so y is a constant in this case. Y is a constant, so its derivative just keep the constant, and x squared is derivative 2x, so it's 2xy. 2xy. And f sub y. And if we consider this one, then again, it's the first term is the same. Since we should consider outside function derivative firstly, so we still have this term 1 plus x squared y is squared. But second, inside function is derivative. Now variable is y, so x squared is constant. X squared is constant, keep it times y is derivative is 1, so just this term. Just this term. If the variable is y, the variable y. Similarly, you could see that g sub x, g sub y, to see the difference. Okay, so now outside function is tangent. Tangent function is derivative is second square, so outside function is second square. But inside will keep it. Inside will keep it. So it's outside function is derivative form. Right? And the inside function x squared times y, so it's the same. So it's similar. I mean x squared times y, when the variable is x, then we keep y is constant, so it's 2xy. So it's the same, 2xy is 10. I mean these two terms are the same. You will see actually these two terms are the same. And the second square tangent, and then if the variable is y, then the first term tangent is derivative is second square. So the first term is the same. And the inside function is derivative. Our variable is y, so s is a constant, so keep the constant as square, and y is derivative 1, so just this term. So it's the same as this one. And this one. So their difference is exactly the outside function is different. Otherwise, the inside is the same. And the difference, outside function is different. They have different derivative formula, but inside function is the same. Yeah. Okay. Yeah, I think it's the example in this section. It's the example in this section. Let me see. And for in this section part, we still have 1 or 2 results. Yeah, I think. Yeah, I think I could tell you in next video. Yeah.